And I think I am live. I think. Yeah, I'm pretty sure I'm live. Okay, so today um, I wanted to start learning Rust um, live on YouTube. And the reason why I am learning Rust is because, well, it seems like a very interesting language. My background is mostly on Java and Kotlin, and I've also done a lot of JavaScript, so mostly with higher level languages, with a garbage collector and all the nice things. So things are pretty abstracted away from me, and I don't need to think about um, memory too much or lower level concepts. And Rust always seemed like a good introduction to lower level concepts. Of course, I also did a few bits and pieces of C and C++ in university, but those days are well into the past, so I don't remember much. Maybe just some fundamentals. And everybody on Twitter seems to love Rust, so I guess I wanted to see what everything was about. To be super fair, this is not the first time I tried to learn Rust. I think it's probably my third attempt. The first two didn't get that far. I basically wrote a hello world once, I think, and then some very simple program to get the battery level from my machine another time, but I remember pretty much nothing. Um, and that's mainly the reason why I'm doing it live on YouTube, because if I am out there and maybe one or two people are watching, then I will feel bad if I don't continue this series. And so, yeah, that's pretty much it. So the goal of today is start learning Rust following this book, The Rust Programming Language by Steve Knabnik and Carol Nichols, with contribution from the Rust community. I apologize to Steve and Carol if I mispronounce your names. I actually think this name is not news to me. I think I may follow Steve on Twitter. That's probably why I think Rust is cool, because if he wrote the book, I assume Steve is a man. If he wrote the book, then probably he's excited about Rust, and I may have seen some of his tweets. So anyway, let's get started. Let's keep all these. We use Rust 4, we don't really care. I know I will probably not use it for work, but who cares? Let's start the Rust journey. There is a ton to learn, but every journey starts somewhere. In this chapter we discuss installing Rust. I already did. Writing a hello world in using Cargo, Rust package manager and build system. So as I said, I already have Rust C installed. Yes. So we don't need to go through that again. And let's start with a hello world. Okay, so let's start by creating a hello world directory in which we will create our first file, main.rs. Okay, so let's start by just straight up copying what it's in print line hello world. Okay, so there are at least two interesting things to note already in this hello world. The first is that it seems that any new modern programming language needs to come up with a slightly different way of declaring a function. I believe Go is func, Kotlin is fun, Rust is fn. That's great. We want to be special. And the second cool thing is this exclamation mark here. So if I recall correctly from my also I cannot spell hello. If I recall correctly from my very brief introduction of Rust, This exclamation mark is here because println is not a function, it's a macro. So the way you do it is the way you use a macro in Rust is by using an exclamation mark. Also, I realized I forgot the semicolon, which I guess is another interesting thing. In Kotlin, they get rid of the semicolon. I'm personally not a big fan, but okay. In Rust, I decided to keep it. Okay, and then let's try to compile it. Maybe I can even use a terminal from Visual Studio Code. So Rust C main, and we do have our binary called main, and it does indeed print hello world. So I guess we know the tooling works. Blah blah blah. Anatomy of a Rust program. So we start by looking at main. The function name main. The main function is special. It's always the first code that runs in every executable Rust program. Okay, of course it has no parameters. For now, the function body is wrapped in curly braces. Rust requires curly braces brackets around all function bodies. Okay, so this is another thing different, for example, in Kotlin, where you can have a single expression function and you don't necessarily need to use the curly brackets. Okay, then let's see the print line. It prints text to the screen. Also, okay, it also notice here that Rust style is to indent with 4 spaces, not a tab. I'm okay with using spaces. I am not a fan of using 4 of them. Usually I use only 2. This seems a bit excessive, but oh well, we can live with that. Second print line calls a Rust macro. If it had called a function instead, it would be entered as println without the exclamation mark, yes, as I was remembering before. We will check out macros later. Okay, the only thing to remember is that if there is an exclamation mark, it means that we are using a macro. Then we have a string, hello world, and then yeah, every statement ends in a semicolon. Okay, we already compiled this. We already see that we don't care about Windows. We already run the executable, blah, blah, blah. Okay, so yeah, of course. So here they go saying that, of course, you need to compile your source code before you run it, not like in some like interpreted languages like Ruby, Python, JavaScript. But I guess we knew that already. Okay, and then the next chapter is on Cargo. Cargo is Rust build system and package manager. So this is again another interesting choice. So like in Java there isn't really a built-in build system and package manager. So there are multiple like competing ones, which it can be good for, I guess, innovation. It can also be bad because as a new user, you have like, if you want to learn Java, of course you cannot just learn Java. You need to learn Java, you need to learn Gradle or Bazel, I think is the name of the build system from Google. Bazel, yes, Bazel. You need to learn Maven or whatever, and instead. But and then we can have multiple competing package manager and build system for Java. In fact, Gradle is relatively new, I guess. But in Rust, they decided to just build their own thing, the default thing. Of course, doesn't mean that you cannot go and write your own custom one. But of course, there will be less incentive for people to try out new things if there is already an ecosystem that works. Personally, I think it's a good thing. At least it will be easier to learn. Okay, Cargo handles dependencies and handles libraries that you can download. Okay, the simplest Rust programs, like the one we've written so far, don't have any dependencies. But of course, more complicated ones, they will. Okay, and the rest of the book assumes that you're using Cargo too. Okay, this makes This makes sense. Let's see if I have a valid cargo version installed. I do. Okay. Creating a new project with cargo. Okay, so we need to get rid of this hello world project and just start from scratch. So cargo. Oh, let me. Okay, no. Cargo new. Hello world. Hello cargo. Okay. So let's see. Hello cargo. Okay, so let's open this in Visual Studio Code. So interesting, we have a cargo.toml. I have no idea how to pronounce his name. That specifies the name of the project, the version, the edition. Not sure what this is. And here we would have our dependencies. And then we also have a source directory with a main.rs, which is the the exact same program we wrote before to write hello world. Interestingly, also gitignore is generated because, of course, we assume that everyone uses Git. Okay, that's probably a good assumption, I guess. So let's see. Blah blah blah. Oh, okay. If you, okay, I guess we can also change when we create a new one. We can change which version control system we use. Then they talk about cargo.toml, blah blah blah. Tom's obvious minimal language. I think I've heard about this, but I never actually used it. A config file format for humans. Okay, that's basically like YAML or whatever. JSON. Is JSON for humans? I would argue yes. Anyway. Okay, but this is pretty much self-explanatory. Building and running a cargo project. Okay, let's see. New terminal. So cargo build. Okay, so we have a target directory with a bunch of stuff. I guess this is the, so it by default it generates what I think it's a debug build, so like, you know, non-optimized and stuff like this. So it's faster to build and easier to debug, probably slower to run, and a lot of more metadata file. Rusty only generated one file. Here we have a bunch of, oh, but they are mostly empty. Okay. So interesting. So, and the target debug hello cargo is our actual binary. So let's see. So target debug hello cargo, hello world. Yes. Okay. Cool. We just built a project with cargo build and run it with target debug hello cargo, but we can also use cargo run to compile the code and then run the resulting executable all in one command. So we can also do cargo run hello world. Let me, okay, and I guess if I change, maybe we can, why Ubuntu, you don't understand, I want to resize both windows. So I guess if I say hello hack and I run it again, it will recompile and yes, okay, makes sense, cool. Blah 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 blah. Building for release, cargo build / release. Just out of curiosity, it would be cool to see like what is the difference in size between the release and debug. So how can I even know? What is an easy way to check? I guess we can just open the files. So debug 4 megabytes. Wow, 4 megabytes for hello world is a lot. But the release one is also 4 megabytes. Okay. Of course, actually, yeah, that was okay. It's probably because there isn't much to optimize, is there? Like if it's just a hello world, so that's probably why. Okay, but we don't care about all these details. Okay, finally a real a real programming a guessing game. So let's just jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts. You learn about let, match methods. I guess let is to declare variables, and match is probably like when in Kotlin, like to pattern matching, I think it's called. Methods, associated function, using external crates, and more. We'll implement a classic beginner programming problem, a guessing game. The program will generate a random integer between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Okay. So yeah, we need a new cargo project. So let's go back. Let's also resize this window. Cargo new guessing game. Guessing game. Okay. Yes, this seems to be. I don't want an extension. Okay, this seems to be correct. Let's open the actual code. As you saw in chapter 1, cargo new generates a hello world. Okay. Yeah, also let's just run it to make sure that things are working correctly. Cargo run, and they are working correctly. Nice. Okay, the first part of the guessing game program will ask the user for input. Process that input and check that the input is in the expected form. To start, we'll allow the player to input a guess. Enter the code into source main.rs. Okay, so how do we want to do this? Should I retype all of this? Probably yes. So we first print out guess the number, and then we ask for a guess. Please input your guess. And then, okay, interesting. So let mute, I don't know how to pronounce it, guess, new string. Okay, so let me guess what this is. Let me guess what guess is. So let is like val or var. So it's basically a keyword to declare a variable. Mute, actually I know what this is. So this means that the memory that guess points to cannot be mutated. So it's not like final in Java or val in Kotlin, which basically means, oh, like you cannot reassign this variable, but you can still change it. Like if you assign a user to a final variable, then you can still change the name of the user. It is still valid. But here, mute is a much more profound concept. It basically means that these strings can never be mutated. And also string new is, yeah, it's basically like, I guess, just like calling a static function on the string class to create a new one. Interesting. And then we need to import standard.io, and to read from standard input. So standard in with read line, and we put the content, I guess, into guess, and we expect, no, we don't expect, fail to read line. There is no formatter for us. Okay, so this I will do for the next episode, I guess. So let's manually indent stuff. So read line, mute guess. I guess this means that we pass a pointer to guess, or a reference to guess. and the expect thingy. So basically, when this function finishes, I expect guess to contain the data read from standard input from the user, and this expect thing tells me that this returns like a promise or like some optional value or whatever, or like some success value, that if it's not there, we crash the program with this message, and then we print line you guessed guess. Okay, this is also very cool. So we can really, does this really work? Like, can I just put the name of the variable like this and it will actually work? This sounds. Please input your input 3. It does work. Okay, so I was a bit confused because the syntax highlighting tool doesn't highlight me this as a variable. But okay, this is very cool. Actually, Kotlin also has this. Slightly different. In Kotlin, you would do something like this. Yeah, cool. Okay, let's see what the book says about this code. So the code contains a lot of information. To obtain user input and then print the result as output, we need to bring the IO input-output library into scope. The IO library comes from the standard library known as standard. So that's why we use standard.io. So I guess that if we just did this and we commented out this code, this should anyway work. Yes, it seems that it does. Okay, makes sense. Semicolon. By default, Rust has a set of items defined in the standard library that it brings into the scope of every program. This set is called the prelude, and you can see everything in the standard library documentation. So, for example, I guess string is here, and indeed it is, so that you don't need to import string every time. Okay, makes sense. Where were I? Where was I? By default, okay, yes, here. So if a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with a use statement. Okay, so basically using standard.io, standard.io provides a library with a number of useful features, including the ability to accept user input. Then we have our main function that we already checked. We have the print statements we already checked. Okay, this is new, storing values with variables. So next we create a variable to store the user input like this. Okay, so let math guess string new creates a new variable in which we store the user input. Now the program is letting it get interesting. Yes, we use let statement to create the variable. For example, let apples equals 5. This line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default. Actually, I think before so in Java you would say, okay, this is final, or like to say explicit, you cannot reassign it, but here by default, you cannot even change the variable content, let's say. So if you want to do it, then you need to specify the mute. I should check how this thing is pronounced. Keyword, because of course this string is empty and we want to change it because we want to put inside of it the actual content of what the user inputs. Immutable by default, meaning once we give the variable a value, the value won't change. Okay, we'll discuss this concept in detail in the variables immutability section. To make a variable mutable, we add mute before the variable name. Okay. So wait, maybe it is like final then, because I assume you cannot just like change the 5. But anyway, we will see later, I guess. Returning to the guessing game program, you now know that let math guess will introduce a mutable variable named guess. The equal sign tells Rust that we want to bind something to the variable now. Okay. On the right of the equal sign, is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. String is a string type provided by the standard library that is growable, UTF-8 encoded bit of text. Okay, so this is already a very strong difference from what I'm used to. In Java, in Kotlin and any other JVM language, you definitely cannot grow a string or change it in any way. But it seems that here, in Rust, you can absolutely do that. The double dot syntax in the double dot new indicates that new is an associated function of the string type. Okay, so an associated function is a function that's implemented on a type, in this case string. Creates a new empty string. You find new function on many times because it's a common name for a function that makes a new value of some kind. Okay, so apparently this new thing is not a standard thing. Like it's just like a convention that when you have a new type and you want to, so you definitely want to create some sort of like a way of creating new instances of this new type, then you write what we in Rust call an associated function to create new types, but you could actually call it whatever you want. This is different from Java when you have a constructor, and a constructor is always a constructor. Although even in Java, we often have static function to actually instantiate new types. But anyway, okay, interesting. So it's interesting to know this, that you can actually just, there isn't a concept of a constructor like a standard thing, but only this is only a soft like a convention. Okay, cool. Okay, in full, let Matt guess. I really don't know how to pronounce this. Is it Matt? Is it mute? Somehow both seem like very weird. Anyway, I will try to say mute, I guess. Okay, so in full, let mute guess equals string new. Linus created a mutable variable that is currently bound to a new empty instance of a string. Okay, then let's talk about this part, receiving user input. We call certain input function to the IO module, which will allow us to handle user input. Okay, if we had an important IO library, yes, this is what we found before, blah, 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 we don't care. The next line is interesting. Calls readLine method on the standard input handle to get input from the user, and we are passing and mute guess as the argument to readLine to tell it what string to store the user input in. Okay, so readLine takes whatever user types into standard input and appends into a string. Okay, without overwriting its contents. Okay, interesting. So basically, so since string grows, is a type that grows, maybe you cannot even replace characters. I don't know. But the point is that you can, if guess had already some characters in it, you could just append them. We could, for example, try. So let's do it twice. So we input one number, I guess 3, then we need to input another one. Yeah, maybe we should also print it. Another one. Let's see. So first guess is 4, second guess is 5. You guessed 4. Okay, so I guess this is a 4 new line 5. Okay. And then there is another new line here for the other 5. Okay, interesting. So readLine will just append. The string argument needs to be mutable, so the method can change the string content. Okay, of course. The ampersand, I think this is called, indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy the data into memory multiple times. Okay, so I don't want to I don't want to compare this to a pointer in C, because I learned this concept too many years ago to be fully, like, not to say something very, very stupid. But I guess this is what would happen in Java automatically, like you pass references and not values, so we don't copy the content of the string And if we want to do that, we use the ampersand command, character. Otherwise, we would have copied this string, I guess. You don't need to know a lot of those details to finish this program for now. All you need to know is that like variables references are immutable by default. Hence, you need to write ampersand mute guess rather than ampersand guess to make it mutable. Okay, yes, so makes sense. Handling potential failure with the result type. Okay, so this is what we're expecting. So readline return a result instead of throwing an exception. So in Java, what would happen? In Java, you would have readline would declare maybe an IO exception on its signature, and so you would need to handle it in some way. Instead, in Rust, apparently readline will return a result type, which has an expect method. Let's see. We could have written this code as, okay, one long line is difficult to read. Okay, of course. Okay, we know this. As mentioned, a readline puts whatever the user enters into the string we pass to it, but it also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one or multiple possible states. We call each possible state a variant. Okay, interesting. So this result thing is an enum. So it can be okay or it can be error, and it wraps either a value t, which I guess is what the method that could return this result wants to return, and e is the actual error. The result is a type that represents either success, okay, or failure error. See the model documentation for details. Yes, and of course it has a few methods on it, including expect. Yeah, expect as long as they contain okay value, consuming this self value. Because this function may panic, its use is generally discouraged. Okay, nice. Instead, prefer to use pattern matching and handle the error case explicitly. Panics if the value is an error. Okay, and if it will panic with this line, with this string message. So basically, as we suspected, so readline returns a result is an enum, can either be okay or error. Exactly. If it's an error and you call expect, and if you call expect on this enum, it will return the value of the result, or it will, if it's an okay, or if it's a error, it will panic the program, which I guess it means it will just kill it, like crash the program, and with this message. Cool. Blah blah. That can be in one or more possible, can be in one of multiple possible states. Yes, we call each of possible state a variant. So basically, R and OK will be variants of the result enum. Okay, but chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. So these I like a lot more than what Java does. Exceptions are really annoying to deal with. I very much prefer this type thingy. Like basically everything is built into the type system. You have a result. You know you need to handle the error. But like in Java, you would need to put this in a try catch. You would need to indent everything. Like it would be so much uglier to look at it, even if you just wanted to crash the program. So yeah, this seems very cool. Results variants are okay in there. This we already saw. Blah blah. Values of the result type, like values of any type, have methods defined them. Yes, an instance of result has an expect method. Okay, like basically this is going through what we already saw. If you don't call expect, the program will compile, but you'll get a warning. Let's check it out. Let's see what this warning is about. Expect. Oh, actually, it doesn't compile. Okay, yes, because I forgot a semicolon. warning, unused must use, on by default. This result may be an error variant which should be handled. Okay, interesting. Also very nice that the compiler can generate this type of warnings. So in Java, you would I'm not sure if actually it's Java C or one of the tools we use at work that will tell you, oh, actually there is a method that returns a value, you are ignoring this value, so what's going on? I believe it's a tool we are using, but maybe not. But it's very cool to see this. Also, this output is so well done with colors and everything. This is the most beautiful warning I've ever seen. This is very cool. Okay, so Rust warns that you haven't used the result. Okay. Placeholders. Printing values with print line placeholders. Aside from closing curly brackets, there is only one more line to discuss in this course so far, which is again this placeholder thingy. This line prints the string that now contains the user input. The set of curly brackets is a placeholder. Okay, and you can also print multiple stuff in blah blah. Okay, but this we don't super care. Okay, let's get to the generating a secret number. So basically, as you may remember, and also as I may remember, I'm not sure, we are implementing a guessing game, which means that we generate a random number, and then we ask the user for a number, and we check if the user got it right or not. So of course we need to generate a random number. So how do we do that? Okay, using a crate to get more functionality. Okay, so we are gonna use a dependency to do that. A crate is a collection of Rust source code files, also known as a library. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code intended to be used in other programs and can't be executed on its own. Okay, so we need to depend from this run library crate. And how do we do that? Cargo coordination of external crates is where Cargo really shines. Before we can write code that uses run, we need to modify cargo.toml to include the run crate as a dependency. Okay, so we add it here, I guess. Okay, and it uses all this like nonsense, whatever, but we are not gonna care about this version. We are just gonna hardcode the version here. Let's see. So I assume that when I do cargo run now, it will actually fetch. Yes, exactly. So we are fetching this library, even though we are not using it. Okay, more and more talk about dependencies. The cargo.log file. Okay, this is just like the package JSON log file for JavaScript. I'm gonna skip all this stuff because I am like not actually super interested in this part. I really want to know the language itself. All these details are like okay, cargo update. All these details are you can learn like when you actually use Rust for a real project, I guess. And you can update dependencies with cargo update. Maybe this we can do. Actually, it's taking forever to download this. Maybe it's because I am also streaming that it's so slow. Okay, but let's see how we can actually use it. But first, I think we need to run this update method because it's possible that between 0.8 and 0.9 something changed. Actually, you know what? Let's just, yeah, hopefully you can recover from this. But let's use exactly what build. And in the meantime, we can continue writing the program. So generating a random number. Okay, so we use actually rand ring, I guess it is. And we generate a new secret number. So this is not mutable, because I guess we really don't want it to be mutable. we call this thread ring thing, and then we generate one random number in the range 1 to 100 with this very weird syntax. Let's see what the book says. Oh, I am missing the secret. Okay, they are also printing out what the actual number is. We call the rand thread ring, I guess, function that gives us the particular random number generator that we're going to use, one that is local to the current thread of execution and seeded by the operating system. Okay, so that's why this is not a new thing, because it will return the same thing every time you call it for the same thread, I guess. Then we call the generate range method on the random number generator. This method is defined by the ring trait that we brought into scope with the use rand range statement. Okay. Wait, what? Oh, interesting. So thread ring or whatever is actually not defined in RNG here. This is defined here. We failed to select a version for the requirement rand. Candidate version didn't match. Oh no. Okay, let's just use 8.3, I guess it was before. Took you forever to tell me that. So is gen range not defined? What do you want? Expect failed to read line. Could not compile. Expected expression. Of course. Then semicolons. So this method is, so the generate range method is defined by the ring trait that we brought into scope with the user random statement. This is very weird. So it's basically like what in Kotlin would be an extension function, I guess, which you can define not in the same like file as the actual type that you are applying to. In fact, I think that if we comment this out, so if I understand correctly, this should still compile. And we also need to... It does. Okay, interesting. I find this a bit strange, not in a bad way, but like yeah, it's just weird. As a Java engineer, this seems a bit weird. Okay. The genRange method takes a range expression as an argument and generates a random number in the range. So this is a range expression. So I guess we have something similar in Kotlin, that you can create a range object with syntactic sugar with the dots in between two numbers. I guess this is something similar. The kind of range expression we are using takes the for start dot equals end and is inclusive on the lower and upper bounds. So 1 and 100 are also included in this range. Okay. So let's run this. So the secret number is 59. Input your guess. I will guess 59. How good am I? Comparing the guess to the secret number. Okay. Now that we have user input and a random number, we can compare them, of course. And we do that by using match. Okay, we compare guess with the secret number, but isn't guess a string now? Okay, let's just copy what the book does. So match guess.compare secret number. Okay, and we have three possibilities. So this very much looks like Kotlin 1. So so this comparison will return an ordering, which we need to import. And the ordering, so this object can either be less or it can be greater or equal. Okay, and so we print too small, too big, or you win. Okay, and we also need a comma here. Whoop. Sorry, I pressed some random thing in my keyboard. Yes, I know, I don't have a formatter. Okay, sorry. So the interesting thing to me is that this guess.compare doesn't make much sense. So this secret number, I guess, is a number, like an integer, but this guess is a string. Let's see. We had another use statement for ordering that we can already know what this is. Then we can add 5 new lines in which we match expression, okay? A match expression is made up of arms. An arm consists of a pattern to match against. Okay, and the code that should be run if the value given to match fits the arms pattern. Rust takes the value given to match and looks through each arm pattern in turn. Pattern and the match construct are powerful Rust features that let you express a variety of situations, blah blah. Okay, we already understand this. Yeah, we already understand also that what this is. Oh, I can see that maybe actually my point about the type is actually correct. Yes, exactly. So expected struct string found integer. So what we need to do is we need to convert this guess into an integer. I guess the core of the error says that there are a mismatch type. Yes. So because one is a string and the other is an integer, a 32-bit. Actually, no. A few of Rust number types can have a value between 1 and 100. Integer 32, a 32-bit number. Unsigned integer 22, an unsigned 32-bit number. Integer 64, blah blah. Unless otherwise specified, Rust defaults to an integer, to an I32, which is the type of secret number unless you add type information elsewhere that would cause Rust to infer a different numerical type. Okay, so this secret number is a number with a 32-bit precision. And of course, Rust cannot compare a string to a number, so we want to convert a string exactly to a real number type so we can compare it numerically to the secret number. Okay, so we need to do this. Actually, let me write it out. So we want to have our guess. Okay, oh, so this is how you specify the type explicitly. I guess Rust, as we saw before, can infer your type. You don't need to write let mute guess is a string like you would do in Java. Like in Java, you would do string equals string dot new string or whatever, which is pretty annoying. But sometimes, as maybe happens also in Kotlin, you actually need to give a hint to the compiler. Like in this type, we want an unsigned integer from guess. So first thing, we trim it. So we remove the new line, for example, and then we parse it. So interesting that basically it means that string has its own internal way of being converted to a number. Cool. And this parsing returns the same thing as this read line because obviously it can fail. So it will return a result. And if it's not okay, we want to panic the program. Please type a number. Semicolon. And now we need to actually, this is also interesting because as you notice, we are reusing the same name. So we are declaring another, we are basically shadowing this guess name here. Interesting that this is possible. Not sure if I like this, to be honest. Let's see if now it works. So it builds, and So if we, so the secret number is 7. If 1 is too small, okay. If I guess correctly, I win. Let's see if I can panic this. Please panic. Oh, thread main panicked. Please type a number. Parse int error. Okay, makes sense. Cool. So we created a variable named guess, but wait, doesn't the program already have a variable named guess? It does, but helpfully Rust allows us to shadow the previous value of guess with a new one. Okay, and let's see if we understood correctly. We bind this new variable to the expression guess trim parse. The guess in the expression refers to the original guess variable that contained the input as a string, of course. So this guess is obviously this guess and not this guess because we didn't yet declared this guess. So we are trimming it from new lines and whatever. The parse method on strings converts a string to another type. Here we use it to convert from a string to a number. We need to tell Rust the exact number type we want by using let guess unsigned 32. Okay. Rust will infer the secret number should be at 32 as well. Interesting. So by doing this, we are also making Rust infer that this secret number is as an unsigned 32. Okay. Additionally, unsigned 32 annotation in this example program and the comparison with secret number means that Rust will infer that secret number should be a unsigned 32 as well. Wow, pretty smart. Pretty smart. Okay, let's run. We already did. Blah blah. We have most of the game working now, but the user can make only one guess. Let's change that by adding a loop. Okay. Oh wow, this is wild. So apparently you run a loop in Rust by literally writing loop. Cool. The loop keyword creates an infinite loop. We'll add a loop to give users more chances at guessing the game. Okay, so basically here, so we of course we want to allow people to try multiple times. What the to try multiple times to guess the game. Let's take a look. Cargo run. So if I put 10 and we get, oh, it's too low. If I put 1098 is too big. But there is a catch. I guess we want to end if I win, right? So the number is 92. Okay, I win, but it will keep asking me for stuff. So I guess we will exit this at some point. Okay, always we can interrupt the program by using the keyboard shortcut Ctrl+C, but there's another way to escape this insatiable monster as mentioned in the parse discussion. If the user enters a non-number answer, the program will crash. Okay, we can take advantage of that to allow the user to quit. Okay, yeah, of course, we can also just print quit and the program will not end, it will panic. It seems a bit... but we also, yeah, we want to quit after a correct guess. Okay, this is pretty simple. So basically here we can pass a lambda, what I would call a lambda instead. So we print like you win and then we break out of the, we break out of the loop. Let's see. So 73 and I win and the game finishes. Okay. Nice. Handling invalid. So actually, so basically like we will learn how to do a very simple loop. Hopefully there are a bit more some ways to iterate an array, of course, that are not like manually breaking inside the body of the loop, but I guess we will see in the next lessons. So handling invalid input. Okay, so basically here what they say is that To further refine the game behavior, rather than a crash in the program when the user inputs a known number, let's make the game ignore a known number so the user can continue guessing. We can do that by altering the line where guess is covered from a string to an unsigned 32 as shown in listing 2.5. Okay, so after parse, we pass a lambda. No, we are pattern matching again. Ah, okay, yeah, I missed this match at the beginning. Okay, I was very confused. Okay, so we match the result of parse, and we can have either an OK with a number, num, or an error with an exception that we don't care, I guess, or with an error message that we don't care, and we continue. Okay, so so interestingly, that I can name the variable here that OK wraps. Okay, we switch from an expect call to a match expression to move from crashing on an error to handling the error. Remember that parse returns a result type and the result is another enum, blah blah. Okay, we know that. If parse is able to successfully turn the string into a number, it will return an OK value that contains the resulting number. Okay, the OK value will match the first round pattern. The match expression will just return the num value that parse produce and put inside the OK value. Okay. Otherwise, we will just continue. Now everything in the program should work as expected. Let's try it. Okay, so let's just try it once more. Cargo run, and of course I forgot a semicolon here, I guess. Let's guess too low. Let's input garbage, and let's input the correct answer, and the program exits correct. So awesome, with one time of final tweak, we will finish the guessing game. Recall that the program is still printing the secret number that worked well for testing, but it ruins the game. Okay, let's delete the print line. Okay, makes sense. Let's not do this. And now we will need to guess for reals. So let's say 10, too small, 50, too small, 100, too big, so it's between 50 and 100, let's see, 75, too small, let's say 85, too big, let's see, 80, too small, 81, okay, I won. Nice. Summary, at this point you've successfully beat the guessing game, congratulations. Okay, and we saw let match functions, the use of external crates and more. And then we will learn about more stuff in the next chapters. Okay, so this was actually pretty cool. I think we covered a lot of things. So my favorite feature of Rust so far is this result thing, and I would guess that this match expression here, which also is an expression I didn't notice before. This match expression is very powerful combined with the result type. If I never used Kotlin, I would also be very impressed by this match expression itself. But of course, in Kotlin we have the same, like we can use one, which is basically the same thing. But the result, the idea of returning a result instead of throwing an exception is very nice. You can see how here is so much nicer to look at this instead of like handling an exception as you would do in Java. So I like it very much. Otherwise, also the fact that generate range is not defined together with the type is also interesting. Yeah. So I guess that's it. This is it for this first episode. Let's take a quick look at what we will see in the next chapter. Common programming concepts, basic types, function, comments, control flow. Okay. So I guess this first episode, let's say, was more of like a general covering of a few things that we will see, I guess, much more in depth in the future. So yeah, I think I will be back in a few days, maybe on Monday or Tuesday. with the second episode. I'm not really sure what the end goal is, so definitely I want to finish this book, and then maybe we can try to implement a few like common basic things. I guess we can write our own like simple web server, or I don't know, maybe we can implement some very simple protocols or whatever. We will see. We will see. You can also write me in the comments if you have any suggestion or whatever. This was my first stream ever, so I'm sure the quality of the audio could be improved because I'm using a very shitty microphone from a pair of headphones from an old Pixel phone that I have. But yeah, let's see. Let me know what you thought about this episode. See ya.